Hello. Give me 1 second. What day is it today? Tuesday? Okay, happy Tuesday. We are back. How's your day? Whew. I had a long day, okay? So we had big deadline and yeah. Okay. So we are doing mathematics, okay? So just still recovering from my shift. Long day, a very long day. Okay, let's erase this and then do the mathematics. We're gonna prove the homomorphicity of t function, okay? What it is this t of a times b is equal to t of a strict union times t of b. Okay, so that's what we need to prove. Okay, so I thought about this, and it may be very simple. It may come strictly from definition of t function t. Okay. What is function t? Well, let's give you some example. Okay, t of 12 is 4 times 3, right? 2 2's, comma 3, which is equal to 2 comma 2 comma 3. Okay? It's a prime factorization of number 12. Okay? So that's our function t. Sorry, my voice is not doing very well today. But and what is 12? Number 12 is 2 times 3, which is also equal to 2 to the second times 3. They're all equal, okay? So by definition, okay, so t is a function where you change this multiplication into dots. This middle dots into commas. Commas. That's definition of our function t. Okay? You have a number expressed as multiplication, product of prime numbers. And actually it doesn't even have, does it have to be prime numbers? Yes, actually it does. Okay? For example, t of 12, right, is equal to what? T of 4 times 3. And does it equal to 4 comma 3? No. Why? Because by definition, this multiplicand, this individual number inside of this multiplicative expression, it has to be prime number. Okay? But 4 is not a prime number, it's a composite number. So by definition, okay, so we need to formally define what t is. Okay, so let's do that. Okay, so this we'll prove it later. We need to formally define what t function t is, because I don't think we have done it yet. Okay, yeah, yeah, it's easy definition. Okay, we kind of did something like that, so yeah, we'll do it. It's easy. A belongs to positive integer set, each of its element, each of whose element is more than one. Okay, two or more. Okay, so uh, that's our assumption. Then t of a is equal to xi, where pi xi I from 1 to, let's say, k, this is equal to a, and xi and ni. Okay, ni, how many xi are there, and xi is a prime number. Okay, that's formal definition of this function ta. It's a set. It's a set function. Okay, so good. We got a formal definition of this function t. Very good. For example, t of how about 36? Okay, t of 36. Four times nine, right? So 2 2, comma 2 3, which is shorthand, is notational convention for us. Okay, yeah, it's shorthand for 2 comma 2 comma 3 comma 3. 4 times 9, 36. Okay, so this is like n1 x1 comma n2 x2. Okay, and you multiply all together and you get back 36. And this guy, the main number, like 2 and 3, they are prime numbers. Okay, I will need to write this down because it's a definition of t is kind of important. So yeah, let me grab my notebook and write it down. Okay. Okay. Let me grab my water. We're gonna have to end this episode early because I talked too much today. So I need some vocal rest. Okay, so yeah, my job sometimes requires me to talk a lot. My line of work, so defined as, okay. Yeah, this condition can come right here, okay? So, all right. All right. Let's take a break, okay? Because I need some vocal rest. Seriously. All right. Take five, okay? All right, I'll be right back. Okay, we are back. I have to very soft spoken because I talk too much today. Okay, so all right. We have to talk about well-ordered set. A set by definition is unordered, but it does not prevent us from ordering it. Okay? So, for example, here we are ordering in an ascending order, increasing order. Put 2 first and 3 second because 2 is less than 3. Okay? So, well ordered set. Although ordering doesn't really matter, but it kind of matter, okay? Okay? Okay, we have definition of t. It has to be prime number, alright? 2, 2, 3, 3, but we order it in an ascending order, okay? So increasing order, lexicographical ordering, okay? It's kind of important, alright? So, but even if we switch around, it's still the same set, okay? So, but it has to be prime number. It cannot be like 4 and 9, okay? No. By definition, it has to be prime numbers. Prime factorization, okay? Did I write this down? I think so, yes. Now, we are about to prove the T distributiveness theorem, or T homomorphism theorem. T homomorphism theorem, okay? Can we do it tomorrow when my voice is better? But it's not guaranteed my voice will be better tomorrow, so we may just do it now. How about I stop talking? Huh? Sure. Deal. I stop talking, okay? I wish I know sign language. Sign language. I wish I do. I think it's a beautiful language. Okay, I wish I knew. But I just write it out. Okay, so. It's a strict union. Strict union. Okay, you just combine everything. Okay, so because in set theory, let's say you have set A. Right? But see what I'm saying? So See what I'm saying? If this operator does not have a circle around it, uh, it's traditional set operator, like set union, set intersection, right? Let's do one more. And I really like doing this. Okay. Okay. Let's take a break from mathematics, okay? Well, let's take a break from it all. Take five, okay? So I'm gonna tell you a story, right? So that has nothing to do with mathematics. Right, take five. Okay. We are back. So you wanna listen to a story? Well, I tell you. Yeah, I broke up with the lady I was dating. Okay, so why? Personality mismatch. So we would fight too often because her personality and my personality is just too different. It's more like irreconcilable difference, or um, yeah. So it wasn't quite working. So we decided we go our separate ways. Okay, so that's that. Okay. Yeah, I'm not such a bad guy, and she is a fantastic person. She's a great person, but our personality is just not quite matching. So we fight all the time. So there's no need for it. It's unnecessary waste. Okay, of emotional energy. I'm an economist, son of economist. So I prefer efficiency, and we don't like waste in economics. Okay, so I suggested to the lady that we break up, go our separate ways, and she agreed. Okay, so yeah, because romantic relationship is always replaceable and substitutable. Okay, oh yeah, I love you and only you, nobody else, and it's so bullshit. Okay, so yeah, it's about sex and money. Okay, so yeah, you can always find somebody else. Okay, so romantic love is very overrated thing. One of the most overrated entities in the universe. Okay, romantic love. Yeah, it's overrated. Okay, so, but that's what I think. What do you think? What do you believe that you and your girlfriends are like meant to be? Uh, well, if you ask me, maybe so, or maybe not. Okay, so well, do I believe in love? The kind of love I believe in is love of Jesus. It has nothing to do with sex or romance or money. It's more unconditional love, love for humanity, sacrifice, dedication. Like that's the love I believe in. Okay, but romantic love, it's very conditional thing. Parental love can be unconditional. Well, it is kind of conditioned on that you are the parent of this child. Okay, but Jesus and love is unconditional. Period. Romantic love is conditioned on attractiveness. Yeah, girls want rich men, guys want sexy girls, right? It's very conditioned on this biological sexiness, sex appeal. For women, it's rich men. For men, it's sexually attractive women. Okay, so yeah, whatever. So you get this? Yeah, the circled operator is multi-set operator. Non-circled operator is traditional set operator. Okay, I better take a nice picture of this because it's kind of pretty, the way it's laid out. Okay, uh, we're gonna have to go back to the basics. Okay, so we have multi-set subtraction, but before you get to that, let's think about traditional set theoretical subtraction. Okay, so A minus B is defined as A intersection B complement. Okay? Which is same as A minus A intersection B. Let's prove this, okay? So A prove just by definition. Prove A minus B is equal to this, okay? All right. This is not multi-set, it's just traditional set theory, okay? So we are stepping back, all right? So this is the left-hand side, right-hand side, okay? So left-hand side by definition A intersection B complement. Right hand side by definition A intersection B complement. By De Morgan's law, okay, BD means by definition, okay, it's not bondage and whatever. It's not Buddhism or bondage and discipline. No, it's not that. By definition, okay. Despite De Morgan's law, A intersection A complement union B complement. Okay. And by this is by distributive law. A intersection A complement union A intersection B complement. A intersection A complement is empty set. Union A complement A intersection B complement. And by absorption law in set theory, traditional set theory, this is A intersection B complement, which is by definition A minus B, which is same as left hand side QED. Okay? Yeah, it's very elementary proof in set theory. Okay, so let me take a picture of this. It's kind of cute. Taking a picture of my legs wrapped up in blanket, which is also cute. Okay. Good enough. Okay. Okay. So in a multi-set, it's kind of similar. Maybe it's the same. Alright, so multi-set is a set that allows duplicity. I mean, not deceptiveness, but the duplicateness, this redundancy. Multi-set allow that. So let's say set A is equal to A comma A comma A. So multi-set. Set. We call this 3a, okay? Now, you have 1a that consists of just 1a, okay? Then, 3a minus 1a is equal to what? It's 2a, okay? A comma a. Okay. Which is equal to 3 minus 1a. 2a. Okay? Have you ever seen anything like this before? I doubt it. Probably this is first time in the world in human history, okay? So mark this moment, okay? And you are privileged and honored by witnessing history in the making, okay? This may not be significant. This may be insignificant, but at least in my eyes, I think this momentous moment, historic moment in mathematics, okay, because it's we are doing conceptual mathematics, which is very elementary, but we delve down very deep, strong foundation. That's our emphasis. At the same time, because I don't know too much advanced mathematics, yeah, I just kind of play around, easy stuff, but it's good, okay? Because most of you probably don't know much mathematics like I don't. So yeah, if you can understand this, it's good, right? Let's take 5 minutes break, okay? Okay. So we are exploring. I'm sorry, it has to be circled. It's a multi-set operator. Okay. We have to distinguish this shit. All right. So if a set operator, we don't circle it. But if it's a multi-set operator, we circle it. Okay. So uh, we use this symbol, right? Multiplication star, but it's same as union circle. I mean, star circle is same as union circle. Okay, so it's strict union. Maybe we should start using this guy. Okay, but whatever. This multiplication is kind of like intersection, you know. Maybe we have to define multi-set intersection. Okay, it's like this. Okay, you have what, a comma a comma a, multi-set intersection of a comma b is equal to a comma a, right? Let's define that. Okay, because I looked up this multi-set in Wikipedia, and they kind of defined it. Okay, so yeah, yeah, we should define this just like Wikipedia did, but not exactly the same way though. Okay, we'll do it our own way. Okay, you ready? Forget about this proof. We'll do it later, right? So we're developing multi-set theory. Okay. We'll do it. We'll develop multi-set theory because it's quite underdeveloped area in mathematics. Okay, so we're gonna make some contribution there because it's undervalued stock. It is important. All right. I give you this. Okay. Set A1. Okay, is composed of the single element A is same as 1A. There's only 1A in this set. Okay, and this is same as 1A, comma, what? I give 5. I give it 30 seconds. What comes after this? Hmm? To preserve this equality. What comes after this? Probably you know, okay, but I give you 30 seconds anyway because I want to drink mushroom vodka. Okay, so freshly picked Alaska mushroom vodka. I told you I would stop talking, but what? Alaska chef mushroom. Oh my goodness, so good. They're good. Oh. There are different kinds. The gray kind, the white kind, and yellow kind, brown kind. I sort it out. I don't mix them. Okay, so because I love authenticity. Oh, mushroom authenticity. Don't call me a racist. Okay, so I'm talking about mushroom vodka, Alaska. Mm. They are good. Oh my goodness, they're so good. Okay, your time's up. Yeah, zero B, comma, zero C, comma, blah 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 blah. There's no B, no C. Okay, there's only one A. Okay. All right. Equals to infinity. A B C D blah blah blah. Okay, so now we need to define the multi-set union and multi-set intersection. Okay, that's what we need to define. Okay. All right. Well, before we define these operators in multi-set theory, we need to define what multi-set is. Okay. Let's step back even further. What is a set? How do we define a set? This mathematical entity, object, a set. Set A and multi-set A, okay, with a circle, okay, multi-set. Instead of circle, we may just do it bar, A bar, whatever. Nah, A bar is like minus A is equal to A complement is equal to what U universal set minus A, right? So yeah, A bar is not good. How about A underlined? Yeah, maybe we'll do that because it's easier than circling. Okay, multi-set. Okay, so A underlined. All right, we'll do that. Okay, because it is important because we are economists. We want to be economical. We don't like waste. We don't have time or money. We don't like waste. We love efficiency. Okay? Efficiency. So yeah, multi-set, A underlined. Traditional set, not underlined. Okay. Good. 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 Hey. What's the use? Why are we doing this? Because it's interesting, okay? I mean, idle hand is devil's playground, right? So we keep ourselves busy so that we don't get tattooed, pierced, become gay, become transgender, plastic surgery. We don't want that shit, okay? So, I mean, if you're injured, you got some scars, yeah, plastic surgery is good. There's some good plastic surgeries to get rid of your scars and from accident injuries. All right. Valentine's. How do you define a set? Oh, So here's the element. Here's the condition, okay? Condition that the element must satisfy. Okay? So the part here that goes in here on the right side of this bar in traditional definition of a set is a Boolean function. It has to be a Boolean function, okay? So yeah, Boolean function b of x. It has to be true. Okay? Yeah. Propositional logic. And there's one more component, okay? And because traditional set theory, x1 is not equal to xi is not equal to xj, because in traditional set theory it does not allow any redundancy. Okay, so yeah, that's the catch. Which is good. Okay, yeah, it has very good property. It's good, very good reason to disallow redundancy. Okay, but then there came multi-set theory in 1970s. It is also important. It has good application on its own. Okay, see how pretty that is, dark blue. Okay, so we'll take a break. We'll go all the way back to the basics. Okay, we are originalists. Originalists. Will adore, admire the old school. I do. Okay, just like some constitutional people. Yeah, some are originalists, like Justice Gorsuch, right? We kind of take that approach. We're gonna go back to the origin, Adam and Eve, God. Yeah, we are originalists. Old Testament, Yeah, whatever. Take 5 minutes, okay? So yeah, think about this, okay? Think about how you define this multi-set A, all right? So how would you define multi-set A? A circle, A underlined, okay? Is what? What comes here? Fill in the blank, okay? It should be very easy if you know mathematics, okay? If not, it's a challenge. No pain, no gain, okay? Yeah, challenge yourself. I challenge you, okay? Yeah, just look up some your cell phone, internet, Wikipedia, or YouTube, whatever, other websites, okay? We'll take a break anyway. Okay, take 5, okay? Right. Okay. So, do you want to take a break from mathematics? Do you? So I can tell you something about uh, my non-mathematical life. Are you interested? It's this, okay? I had many, about 2 dozen relationships in my 4 decades of my life. 2 dozen relationships in my 4 decades of my life. It's like what? If I had 20 relationships so far, yeah, I started relationships when I was like 20, so I'm 40 years old. So if I have 2 dozen, about 20 relationships so far, it's like one relationship a month or a year, not months or year, okay? Because before I was 20, I didn't have any relationship, short term, long term. I never had long term relationship, by the way. Okay, so yeah, one relationship a year. Okay, was it a year long? No, 1 month, 2 months, 3 months. Okay, so sometimes I wanted the relationship to last longer. Sometimes I wanted it to last shorter. Okay, so but I was always polite. I was never violent. I was never rude, mean. Okay, I respected them and they respected me. In a sense, I've been fortunate. Okay, so but if you are in a toxic relationship that you fight all the time, you need to break up. Okay, but what if the other person wants you still, and then you have to be nice. Okay, and try to appeal to their reason, not emotion. Okay, so that's the key. Because you don't want to escalate your breakup into some kind of violence or crime, right? So yeah, just try to understand, tolerate for a while, just play this game or break up, so maybe a little bit longer. Okay, so uh, it's very important that you care about other people, your ex. Okay, so yeah, that's my 2 cents for you. Okay, yeah, just play a little longer, like a fishing game, whatever. Okay, so, but just be nice, be non-violent. That's the key. Don't ever be violent or abusive. Be nice. Appeal to the reason. Okay. All right. So what's this? Ah, you just take out xi is not equal to xj. You just take out that. If bx is one, that's what this guy is. Okay. So okay. Yeah. You just take out this anti-redundancy condition out of there, then yeah, you have multi-set definition. You want me to spell it out for you? I'll do it. Okay, that's it. All right, so we got this, and we'll call it a day because I need some vocal rest. I gotta eat, sleep, and go back to work tomorrow. Go back to work tomorrow. Okay, so I have to do that. So, all right, thank you. Good night. Bye.